मनीषा मैडम, हेलो मनीषा।
Hello, am I audible?
हाँ येतोय.
Start.
हाँ येस.
Okay. Good afternoon to everyone. Myself, Professor Manisha Bansode, welcomes to the AICT sponsored 2-week FDP on insights into intelligent automation, machine learning, data science, artificial intelligence, and machine. So it is a great pleasure for me to introduce today's session guest, Mr. Sir. Mr. Amar Patel sir is currently as Area Service Manager at Qarmatek Private Limited. He has qualitative experience of over 13 years in operations management, quality process management, and team management, and is skilled in developing technical support, empowering consumer self-help, and providing partner advisory services. He is experienced in managing escalated customer issues, which includes direct customer communication, interaction. He is capable of managing and leading teams for running successful process operations and experience of developing procedures, service standards for business excellence, with excellence in working in collaboration with operations management in reviewing, scrutinizing, and developing efficient and effective operation process flow. He is versatile, high energy professional, successful in achieving business growth objectives within turnaround and rapid changing environment, with excellent communication, people management, analytical, and problem solving skills. His technical skills are MS Word, Advanced Excel, Outlook, Word Perfect, RF scripts, design using Aeroflex, Lecter, and the scripter, Python advanced programming, machine learning algorithms. Welcome, sir. Request to join today's session.
Thank you, Manisha ma'am, for a brief introduction of mine. Good evening, everybody. So my name is Amar Patel. So I'm taking today's lecture on behalf of Sovereign Consultants for this group. So they're very much excited. So let me update you. I've never taken such session in past as well. Yes, face to face we have taken a lot, but this is my first ever online session which I'm conducting with such a big group. So welcome all. So we can start the session.
Yes, yeah. I have given you the access rights. You can share your screen.
Right. So team, please confirm over the chat. I have shared a collab link for today's topic, which is principal component analysis. So please do let me know if everybody has received that and they are able to access that notebook. So, hope team, you are able to see my screen. So the topic name which we're going to conduct is why and how to reduce the features. And what is this feature selection versus feature extraction? So I hope everybody are aware of how to use the Colab notebook in Google Colab. So if anybody have any issues, please do let me know. I'll definitely help you out during the time of session. So basically these sessions we're going to have for 2 hours. So let's start with this. What is this feature selection and feature extraction? So team, everybody know that the data science, that ML, which works on the data. So everybody thinks that the larger the data is, the better I can make a machine model more perfect. But let me tell you, team, it's not like that. So what happens if we have a large data set, right? So if we have a large data set, generally with that data set, one of the biggest challenge, it's the model which we make, either it is more overfitted. So you must be aware of underfitted and overfitted model. So if our model is more overfitted, so if any new information we provide to our model, it will be very biased to some of the features which is taking that information. So to avoid, to minimize this issue in our model and make it more efficient, we use this method of feature selection or feature extraction. So let me start with feature selection. What is this feature selection? Uh, so So what happens is machine learning, as the dimensionality of the data rises. I've already explained. So the amount of data required to provide a reliable analysis growth exponential, right? Bayman refers to this phenomena. It's called as curse of dimensionality. So what basically happens over here is, if you see the graph, if you observe it, the moment the numbers of variables or features increases, the performance get degraded, right? So to avoid this issue and to find a sweet spot, we call this in a data science language, we call it as a sweet spot, which explains which features we need to select it from our data set. So what I suggest team, there is also a video link being added about this feature selection and feature extraction, from whom I have learned data science, the Rocky sir. So anytime this link is available in YouTube, you can go through that link. Whatever I'm going to explain it, they have very much deeply explained every information into this video. So right now I'm not going playing this video. Later on, people can go through this video. That will help you a lot to more understand what is this feature selection and what is this feature extraction. So let's start with feature selection. Here, generally what feature in layman language, right? The feature in machine learning language, we refer to the columns, the number of columns we are having in our data set. So rather than we say it as a columns, in machine learning language, we say it as a features. So if, say an example, you have a data set, right, a huge data set, there, if we say n numbers, let me explain to you on the pad. So say example, draw line. Oh, sorry. Say an example. Oh, come on. N is your number of rows, and or we call it as a sample. Samples. And P, we call it as columns, which is, as I mentioned, it's features, right? So what happens is, an example, if we have like 100 number of rows, 100 informations are there, and we have 5 features. So we call it as a good data set. Now you can say, what if there are 5 number of rows and 100 columns? Again, that's a big database. So what happens basically, that we won't say it's a bad database. We call it as a uncertain database, because what happens is it will have a bigger impact on your output variance. How? Let me explain to that as well. Say an example, you have 100 features of data, 100 informations are there, 100 features are there, and to commute these 100 features, again, we require a huge memory, a huge GPU system to read the data. And again, after that, we won't have any certainty that this model will work perfectly or not. So for that, we uses this term feature selection, where we select only those features, those columns which are highly uh, uh, correlated with your output feature. So I hope everybody are getting what I'm trying to explain. If you have any questions in between, please do ask me. So I hope till here, what I'm trying to say, it's clear to everybody. Okay, so let me continue. So the process in this, we call it as dimension reduction. So this method, what we doing it, it's called dimension reduction. How this feature selection to take place, right? You maybe have a question that how this data is getting reduced and how the selected feature we are doing it. To do that, there are particularly in machine learning, There are many various methods are there, but typically we are using over here is first is threshold based method, and second one is a variance based method. So I'll come through that, what is threshold based method and what is variance based method. Threshold based method, generally we use it in a text document where we need to read. So an example, a document is there. There are more than 10,000 words are there, and we need to process that document. We uses this method of we call it as threshold based method. This threshold based method works on a term called, we set up a limit of threshold where according to our requirement we can select only those features which have a certain threshold limits. So here I have one example for you guys. You can go through this text code as well, which I have shared with you. So if I run this code, we are importing the library NumPy and pandas as NM and pandas as PD. These are the two very important libraries which every data set every machine learning codes require. I have imported from sklearn feature extraction.txt imported counter vectorization vectoral. So I call CV and count vectorize, where I have defined my threshold with, like here you can see minimum define is equal to 0.1, maximum 0.8, and maximum features what we're going to use is 2000. I'll explain you more in detail what is this mean DF and max DF. Say an example, guys. You have a big document of say 10,000 or 20,000 words, and there must be some words which are not frequently coming into that text, into that book, into the document. So we can remove those kind of words which are not frequently occurring. So that term, it's called mean DF. So that, like here I have used the parameter of 0.1. So that means whichever words are occurring less than 10% in my whole document, I should ignore those words. So I don't require those words. So that will get removed. Now, on the other hand, there must be some words which are constantly occurring in each and every documents. If they are constantly occurring, again, we don't require those words. So that we are saying is, if any words which are more than 85%, again, remove those words. And what will happen? Our data set will get reduced, right? It will reduce 10% of words which are minimum in usage, and maximum 85% of words, 0.85, which are more frequently coming. And in that, after that, this, what is this max features is, whichever are the maximum we go is a 2000 words. So whichever are the first 2000 words, just select after removing this mean DF and max DF, whichever words are left, whichever features are left, select only 2000. So now what happens is our complete database of word has been reduced from 10,000 to like 2,000 vertical words. So once you execute this code, team, you will see count vectorize gives you analyzer, what kind of analyzer it is doing. It works on word. These are the suffix which are used with this code vectorizer. This is a by default uh, code of threshold based vectorization in machine learning language. So these are the syntaxes which are being used. If we don't mention these terms by default, so you can say analyzer works on word, binary is false, date code it's strict, data type it shows you the data type, what data type is. So you can say it's a numpy integer, so it's an integer based. Unicode is UTF-8, and you can see, guys, we have mentioned minimum D5.1. So you can see it's showing you minimum D5.1, max D5 8.5, so max D5 8.5, and max features 2000. And by default, n-gram range is 1 to 1, and the rest is self-explanatory. And tokenizer, we used it in 1. So when you go further with these sessions, you will come across when you start doing text analysis, you will be knowing more about this vector analyze. So this is what we call it as threshold-based method. So with the above code built on count vectorize, which ignores feature terms, words, which I've already told, which occurs is less than 10% of total compass. So guys, compass is the whole document, collection of whole document. In machine learning, we call it as corpus. So corpus, and also ignore the term which are more than 85% of the total corpus. And basis on that, it put the hard limit of 2000 maximum features select. So this is a feature selection. This is how the feature selection is getting done using threshold based method. And as I mentioned, generally this method is used more on text based data. Right? Now, the second method is variance based method. And this technique, we use it generally on numeric data. So how this method works for this, it's better we go through the coding. Why using the coding, I can explain you this variance based threshold, how it's going to work. So asking for the link, let me put on chat again. So I think Vaishali Suryavanshi is asking. So Vaishali, I've shared you the link. So please do confirm once you receive the link. So I hope everybody are going through this code. So there is a link which is given in this code. So please, if everybody can download, this data set. So just click Control Panel and you can download. So once it get download, so very small database, so not even in KB, so you can easily download it. basically this code is used in Google Colab, where you can import a file. So if you run through this code, it will ask you to choose the file. So just wherever it is downloaded, just selected this file. So it will load that file into our Colab book to see whether it's been loaded or not. So if you click on this folder option, file option on your left hand side, so you can see that book has been uploaded into our Colab. So I hope everybody with me. So show you some this Pokemon database, how this database looks like in a CV format. Okay, basically Pokemon, the game has generated in different, so this is a dummy data team, so it's not a complete set. This has been downloaded from online site. So you can see there are a number of features. What we are having is total we have 13 features are there. Name, type, total type, total HP, attack, and the important what we are looking for, the generation. Which generation we need to. So here what we have done it after loading this data set, we have defined our data set as DF, object as a DF. We have read that CVC file using pd.read.cvsa and the file name. So, and in that, what we have done it, team. So I hope everybody must be aware that to work variance-based method, as I said, it's a numeric data. It works only on the numeric data set. So if anything which is uh, uh, text database, we need to convert into a numeric data set. And to do so, we can use one-hot encoding. So you must be aware of one-hot encoding. If not, definitely there will be a sessions which going to be conducted regarding this one-hot encoding. So basically what one-hot encoding do, one-hot encoding converts your text data into your numeric data. I'll give you one brief uh, uh, explanation how we do. So it will be very much clear to you. So it's an example. You have 2, 3, 4 data set. 4 features are there, and the number of entries for feature 1 in call 0, 1, 2, 2, and 3. Here the 1 is coming over here for one time, so it will put 1 over here, and rest will be kept as 0. It's an example. In other data, in other sorry, sample 2 is coming 1. So what it will do, one hot encoding do, so it will keep all zeros and only that feature will be kept as 1. So that's how it's continue as many samples we are having. So to do so, we use this method, we call it as dummies. So pd.getDummies do the same thing. So what it is doing here, so we have loaded the dataset, Suvarna ML Pokemon, and we have created one more data set of dummy data set where we have used this command pd.get dummies, where we need to apply on our data set where the feature is heading is generation. So when we load this and we have printed that heading. So once you run this command, so you can see guys, first if you take Pokemon dot header, so first 5 uh, rows or samples, it will be displayed. So you can see it. So whichever is generation 1, you can see it's 1, rest is 0. It's not like there are no other ones over here. So if you go through the complete data set, you will let tail as well. So if we type print, dot tail, and execute that. So you can see there are total 800 samples are there. So generation 6 and the bottom is showing 1. This method of converting a text into a numeric integer, it's called one-hot encoding. That is explained on this next set of instruction. So we need to remove the features from this one-hot encoding feature where the variance is less than 15%, right? So team, you can, this numbers can vary. It's depend upon the requirement of your data set, or what you want to go through it. So currently I am taking as 0.15, which is 15% is my threshold. It's a variance. So what I'm trying to say over here is I want to take from these generation, from generation 1 to 6, I want to see which generation is impacting more to my output data, right? So that means if I change anything over here, if I change, as an example, if my generation 1 is highly correlated with my output data, and if I change my generation 1 data, the output is getting impacted. Either if I increase it, so how it's getting impacting to my output data. We generally call it as delta. Changing the delta, we see how much variance is coming to the output. To do that, we use again sklearn. So sklearn feature is a library where we are importing one command which is variance threshold. So this is a by default uh, coding has been done to this library. We are just importing that library, and this will help us to select the features which is having our required threshold limit. So again, what I did it, I create an object as VT, variance threshold, and threshold limit, I put it as 0.15. And then after that, what I did it, I just fit that to my Pokemon uh, data set. So here I got a Pokemon generation data set, and I'm just running through this code. So once I run this code, you can see, guys, it's not giving output currently. So that my code has been executed and my variance threshold, it's 0.15. So I hope everybody is going through this code which I'm trying to explain. So if you guys have any question, please do let me know. So till here, any doubt, any question team, please feel free to ask me anytime. Then the next the coding, let's see like how this threshold variance has impacted showing in our data set. So for that, what we have done it in this code setting, we have created a data frame in the key value pair uh, method. So in this pd.data frame, what I have given a name, a key name as variance, and what I have selected in variance, this vt dot variance. So this code, this variance code, whatever the coding has been done at the backend by the expertise who has built this variance threshold, they have one term in that which gives you the reading, which gives you the limit of these variance. What is the variance of all the features? And selected features again are this is a name guys which we have given to our key value, and vt got get dash support gives you whether it's within our threshold limit or outside our threshold limit. And indexing of Pokemon game into columns, I just given again index I have given as a Pokemon generation columns. So columns name what we were having it was generation 1, 2, 3, 4, and dot t. So again dot t, if you search in Python, dot t means transpose. So everybody must have used in Excel, and they have transport their rows into columns and columns into rows, that transport method. So by default, we have given. So whatever data frame is getting created, it will show us into transform form. So that's why we are using dot .t. So if I run this code again, so you can see guys, variance, the first term as variance, I've selected it. So generation 1 is having 0.16, 16%. Generation 2, 11. Generation 3 again 16. Generation 4, 12, and so on. And now, which features we have selected, right? As we have given the threshold of 15%. So whichever is more than or equal to 15%, it's going to say as true, and other is. So this get support gives you a Boolean output, either true or either false. Is it clear? So now you can see that generation 2, generation 4, and generation 6 are very less. I won't say it is not influencing the output, but it is not that much what is our requirement. So now we need to drop these features out. So to do so, we again have this code of instruction where what I have done it, we have selected again an object name as Pokemon generation subset. And now I'm using a code of iLocate. So basically what this code is doing is, from the Pokemon generation, iLocate, if you go through that, so what it is doing for my all 800 samples, for all 800 samples and 6 features, select only those which are true. So for this code, you can see that iLocate is selecting those from all our data set which we support, it's true. So what basically this is showing, if I run this one, so and dot head, it's again top 5 will be shown. So print Pokemon generation subset, and I'm printing that. So let's run this code, team. What you can see, guys. So whichever features, what? Oh, sorry, it's too much movement is happening. I change my mouse so that it can be visible in one screen. Okay. So whichever in the previous code, when we run it, whichever was true, only that one is selected. Right? And now, whichever model you want to create, linear regression, classifiers, random tree, random forest code, you can now apply to this Pokemon generation data set. So this is what it's a feature selection, and two methods of feature selection we have covered. One is threshold based method and another one is a variance based method. Okay. Now, the next topic which we're going to cover is the part of the same. It's now feature extraction. So more or less feature selection and feature extraction are same, because they work on a reduction of our features to eliminate the curse of dimensionality to our data set. The major difference into that feature selection and feature extraction is, right, one which is very common. You can search it out. In feature selection, we are actually dropping those data sets. We are actually not using it completely. So what happened is, in some scenarios where the customer requirement is for as a programmer, for us, we can ignore that part. But say an example, you have a client and uh, he said that this data, one of the feature, it's very, very important. You have to keep that. You cannot ignore that information, right? What happened in that case? If your model, you have prepared a model and using feature selection, and it is saying it is less important, so you dropped it, but that model won't be accurate, and that model will not solve the purpose of the client, right? So that for that purpose, we can go for the feature extraction, right? One more term point where you can use a feature selection and not a feature extraction is, you are familiar with your data. It's an example. You must be working in a banking term. So banking, you have profits, loss, increment, decrement, and the lots of terms are there. Technical terms are there. For example, there is somebody, a lawyer, and he has some legal terms are there. So he's familiar with the data. He knows what exactly the data is. So he can go directly to the features selection. But what if he's not familiar with that data? He don't know what that term is. Is that data is really important or not important? So in that case, we can go for a feature extraction. So that's is called the term feature extraction. So how we do for the feature extraction is, let me go read it out this term for you. Feature extraction create a new variable as a combination of old or original features to reduce the dimensionality of the selected features. I'll explain you how it works, right? Actually, techniques under feature extraction find as many new features as the old one. So I know there will be lots of questions coming to your mind. कि पहले भी, if I have n number of features And now with feature extraction also, I'm having n number of features. So what's the point of doing this feature extraction? I'll come back to you, team. I'll explain you how that it works and how this is very much useful for the unknown data set, especially for the unknown data set which we are not aware of. But retain only those new features which have higher influence onto the target variable. So whichever is our target variable. So even though it's create a new feature, including our old features, but it will keep only those value which we decide it's highly targeting our output variable. Okay, so this is how the feature extraction works on. And there are basically two types of algorithms in feature extraction. One is linear and another one is non-linear. So the graph pretty much is showing what is linear extraction and what is non-linear extraction. In this session, guys, we will be focusing more onto our linear feature extraction. Again, is a good video has been put by my sir, Rocky sir. So you can go through it. He has explained it completely about this feature extraction. And whatever I'm explaining, it is there into that video and much simpler method, guys. So I'm telling you, once you go through this video, you will be knowing what is PCA. So what was today's topic was more on the PCA side. So PCA means principal component analysis. So this video will explain you complete what is this PCA method is. So as I mentioned in the feature extraction, we are going for the linear method. In that linear differentiate method, to extract the most important feature from the data set, which is having the maximum variance to the output. There are again many techniques are there. Linear discriminant analysis is there, which we call it as LDA, factor analysis, and principal component analysis, PCA, which we are going to use in our today's lecture. Today's notebook, we are only focusing on principal component compound analysis. We call it a short PCA. So principal component analysis or PCA is a statistical technique to convert high dimension data to low dimension data by selecting the most important feature that captures maximum information about the data set. Right? So what I suggest, guys, you can go through this note. So later on you can read all this point. I'll quickly explain you how this feature extraction and the principal component analysis works and how we can use it in our data set. So the one of the most important thing, guys, while using this PCA method, first we need to normalize our features. I hope everybody knows what is normalization of the data set or a features. Here, one of the example is given. What happens generally if the readings here, what the readings has been given in scale, one feature is having in kilograms, one is light year, and another one is millions. So you can see if you convert that, if you apply your model directly to this data set. So what will happen is your model will be more biased towards the reading which is having the higher influence, right? Not to the one which is having the lower influence. I can give you an example. When we do a profit and say an example in banking system, we have a data set which we can tell it's a defaulter or not default. So say an example, you have a data set which is having more defaulters and there are less or non-defaulters. So once you prepare a model in such uncertain data set, what will happen? Your model will be more biased to the defaulters only. So even if you put unknown data to your model, it will show you that this guy is a defaulter. This is just one of the examples. So to make it uniform, that numbers to be uniform, we always normalize our features. So it's highly recommended to everybody. Whenever we prepare any test or train model, first we normalize our data. So in next lectures, in next note, you will be learning, in next sessions, you must be learning this normalization of feature, right? And finally, the last point to remember before we start coding at PCA in a static technique, we can apply this data only on numeric data, guys. As I already said in the past previously as well, that this feature extraction work only on numeric data. So if you have a categorical data, so you need to convert that categorical data to the numeric data before applying a PCA technique. Now let's come to this PCA technique. Sorry guys, but I'm not good at this paintbrush usage. So let me use. Okay. So how does feature extraction principal component analysis work? This works on a weighted average mathematics. So you can go through online. Whoever are from the mathematical background, they must be knowing this weighted average mathematic technique to create a new feature. So let's say an example is we have a data set having 10 features. So we must be having 1, 2, 3, 4, 5, 6, 10. 10 features are there. So what this PCA technique will do and how it creates a new feature. So what it will do, whatever is your target variable, so it will change the value of this feature, putting the high weightage to say an example of feature 1. So this is your F1, F2, F3, F4, F5.
Amar,
Yes,
Amar
sir.
Rathod sir, we can see your code. We are not able to see, I think, your other application which you open.
Oh, sorry. 1 second. Let me close this out. Save. Are you see now, sir?
No, only this collab.
But it is showing me sharing. Let me change it 1 second.
Yeah.
Share context. Okay. Are you able to see now, sir?
Yeah. Notepad
Right.
we can see now. Yeah.
Right. Okay. So guys, let me start it again. So say an example, you have a data set which is having a 10 features. Right. I'm using a lot of time this features because when we have learned the data science, we forgot about rows and columns. Now we are not talking about rows and columns. We always says sample and features only. So say, as I mentioned, we have, let's say an example, 10 features are there and n number of the call, and there is a target variable. Target variable, which is our output variable. I name it as T1. So what this PCA technique will do, it will put a weightage on one feature at a time and see what is your output getting change or variance. What is the variance factor? So what it will do, it will create new feature one, right? By changing feature one more, okay, and rest features F3, F4, F3, F4, and till F10, it will leave it as it is. It won't do any changes to F2 to F10. And the new feature which has been created uh, after changing the delta, the T1 say it's change, it maybe go up or go low. I'll put a value, say an example, it changes by 0.2%, say 20%. Okay, I'll put a percentage over here so it'll be much more clear. So it says 20%. Similarly, it will go through, it will create new feature. Now it will it will change F2 accordingly, and remaining F1 and F3 to F10 won't change. And again, you will give some difference in output, variance in output. Say an example, right, is 0.1 or say 10%. So till now you must be clear what I'm trying to say. And similarly, it will go for NF3 new feature 3, 4, 5, 6, 4, NF4, NF5, and so on till NF10. It's an example, this NF10. So F10 will get changed, put more weighting on F10 rather than other, and F1 to F9 will be same. And now again, this will give you some value, say like it gives you 70% or 80%, you can say. And these also will give you some. So this is how PCA analysis works on your data set. And now it's up to us how many new features we want to select it. Okay, so it depends upon this new feature. So if you want to say you want top 3 to be used, right, or top 2 to be used, so we call it as n compound. So how many n component we need to use? So if you say 2, right, so what PCA will do, if you say 2, so PCA will select only NF10 feature and NF1 feature, right? Is it clear? Because we have said that you need to select the first 2 highest feature, which is giving my target variable more influence, right? And this can vary. You can say 3, 4, 5, whichever. It's your depend upon your model requirement. So this is, we call it as principal compound analysis. This is a technique which is being used in backend. So we don't have to create a complete code for this thing, team. Machine learning in Python, there is already a predefined code is there. We just have to import that library, execute, apply to our data set and see. Is it clear? Right? So now is down. I hope everybody can see my notebook back again. Okay, good. So let's start applying this PCA technique. So to implement PCA technique, again, the very known library in machine learning Python is scikit-learn. We call it as scikit-learn. So in scikit-learn, there is a coding has been done for this PCA. So we are importing some of the libraries. Import cborn as SNN, import numpy as NP, import pandas as PD. So this SNA, PN, and PD all are the objects we are creating to our libraries, and import matplot. So generally this is not required currently. So we are not plotting anything. So if you have learned plotting, so you can do plotting as well. So we call it as heat map. So with the help of heat map also, you can see that. So currently we are not using it. And from sklearn, I'm importing SVM data set. So these are libraries, and I hope everybody are clear with this import warning and warning filter warning. So generally we use this for the coding purpose. What happens is sometime while executing it in Colab, there are some error codes which we can ignore it. But still it get executed. So to avoid such error, we use this code, and this is default. It is there, import warning and warning out filters, and just ignore it. So we are ignoring those warnings. Okay. Now in Python machine learning, there are many default data sets already available in the predefined libraries. And one of the famous, very famous data set is Irish data set. So what we are doing over here is creating a variable or an object called Irish data set and importing that data set from SNS. So which is cborn. So I'm from SNS, I'm loading the data set, which name is Irish. And from Irish data set, I'm printing it out first 5 samples of it. So let's execute, guys, this code. So you can see from the code that we have some information. So if anybody is new to this Irish data set, let me explain you what is this Irish data set. There is a species of some tulip flowers. They got some names, Setos, and there are others as well. So they are getting defined by their sepal length, sepal width, and their petal length and petal width. And on that basis, whether what species it is. So species is our output variable or target variable, you can say. So depend upon the information provided of that particular flower, this model, whatever model we create, it will gives you the information. Is it which species of flower it is? So this is what all about this Irish data set. So I hope everybody must have load this data set. Yes. Okay, good. Now let's process this data set. So I hope you are aware of this train and test model. So let me update you what we are doing it. From this complete set of data set, I'm taking out my X variable and Y variable. So X variable is my input, right? So here what I'm doing, I'm taking my Irish data set, dropping the feature which is species, and access is equal to 1. So I hope everybody knows if we put access equal to 1, that means column wise, it will keep all the data, all the columns except species column. So what will happen over here is, let me explain you guys like finding it out. Uh, come on. Okay, so I have disabled till Y, and I'll just print X for you. Print. So if I run this code, I'm just printing. See guys, so it selected 150 rows and 4 columns, and it dropped the species column. And then Y, which is my output variable. So I am keeping this Y data set of species. So your data set now is got split into two different variables, X and Y. Now we need to use train test split. So train test split is again we are importing from sklearn model selection. We are importing train test split command, right? So what this train test command do? So if you click over here, so you can read it out. It splits your array into two variables, X and Y, which is train and test. So there will be 4 sets will be created. One is your test data set, and one is your train data set. So X train, X test, Y train, Y test, and I've applied this train test split into my X and Y. So the train test splits syntaxes are X, which is your input variable, Y output variable, and this defines your test size. What should be your test size? So here I have suggested 20% of my overall data set. So what this code will do, out of your 100%, 20% of data set, it will be reserved for testing purpose to check how accurate your model is. So it is removed. So this generally in data science or machine learning, by default, we do 20%, 80-20. So 80% your training data set, 20% for your test data set, right? Now, as I told you previously as well, before doing any PCA technique into your data set, we need to normalize that feature. So to normalize it, there are different techniques of normalization. So here I'm using standard scalar. There is mean max scalar also, robust scalar also, but you must have learned it in your this whole course, there will be this normalization process also of feature set. So I'm using standard scalar for this technique. So again, SK learning pre-processing, I'm importing this standard scalar, assigning it to a variable SC, and I'm fitting that to my X, right? Directly to my complete data set, right? Not to my trained data set, which I've already split it, not to that. If I normalize that data set, it won't help you guys. So the overall data set, I'm applying that standard scalar, fitting it to my X, and then transferring that my trained data set, right? And to my test data set. So this technique is called a standardized normalization. So what I have done it, I have first normalized, I've created a standard scalar normalization code applied fit to my X data set, input data set. So normalize we generally do to our input data set only, not to the output data set, not to the target variable. Okay. Now I'm applying my PCA to that. So to apply to PCA, from sklearn.decomposition import PCA, and I'm applying that PCA to a variable called PCA. And now there is a method, right? In a train test model, you can directly transform and fit your object to your train data, right? So there is one more method. This is you transform it and then fit it. And there is another method where you fit and transform at the same time, right? As we have already normalized our data, so we can directly fit and transform to our train data and then read that out. So X-train data where I applied fit and transform my X-train data, and then in my test data I have applied that transform PCA. So whatever is the PCA I have applied to my test data. So now if I run this complete code, right, you can see that the code has been executed, which created a PCA object under the name of PCA. We do not specify the number of components. So guys, as I mentioned in my example, which I've shown it in, over the which features we need to select it. So by default, when you run this code, it will select all 4 of them. So here is an example. We have 4. So by default, it will take all the 4 features, right? And now to see what is the ratio of our features, right? What is the variance? What is the influence to your output to our 4 features? So to get the same, I've created explained variance, PCA.explained variance ratio. Again, by default, this is a code which is predefined in PCA. So we just need to type this code and see the variance. So if I run this code, so what it will do, it will create an array, right? Array of a list where it will give you what is the percentage of that particular feature. This is the PCA value, right? So you can see first data set was stepple length, then stepple width, petal length, petal width. So stepple length is having the highest of delta, the variation to my target variable. It is 74%. So its average is 72%. So you can see the first principal component is responsible for 72. Guys, it keeps on changing. So if you keep on running this code, the values keeps on changing, because the more and more you run, your data is getting more and more read by your model. So keeps on changing. So here currently it is coming 74.7%. Similarly, second one is 23. Here it's coming 21, and so on, right? So you can say it, if I can use only first two feature which covers my 95% of my data to classify any model, right? Is it clear, team? So any question, any doubts? Okay, good. So let's uh, do this uh, again with by selecting one PCA component, right? So for that, again, I import this code. No need to use this code again and again if you have already executed in the previous command. No need to execute again. But generally, as a programmer, we have a habit of typing it out every time. So because we don't like to go up to check it out whether we have imported or not imported. So it's better we every time get imported. So again, I've imported my PCA. Prior to that, created a variable. Now, if you see, I have defined my n component, right? So to see what is the syntax is getting used in PCA, so you can see there is n component, right? Number of components, copy is true, whiten, false, and solver. These are the syntaxes getting used in PCA. It's depend upon the requirement, and we can select accordingly. So I've selected only n component. My n component now I'm giving as 1. So if I select 1 as my n component, so everybody now must be knowing, so it's going to select only my one feature. It won't select my second or third feature to that. And I've applied that PCA fit to my X, then transform, and then transform to the test, right? And to make a prediction of my model, so what I'm doing is I'm using a random forest classifier over here and applying that classifier where its maximum depth is 2, random state is 0. So what happened, guys? Why we are using random state as 0, right? As I've shared you this data, if I don't put anything over here, I remove the random state. So what will happen? Your data, when you execute your code, you will have some different information, right? Because what will happen if random state is none? So while reading your model, it will select any random set of data. So say A, if a random state is none, A will have output of say 96%. Very good. He will think it's very good. B will have maybe 80% accuracy. So to have a common accuracy, we are keeping this random state everybody as 0, right? This is the purpose of this random state, so that everybody should have the same kind of information when they execute. And number of estimators is 10. So everybody must be knowing that the random forest classifier, what depth it need to go, how many estimator, how many times it should execute it. So it is 10. So once my model is getting created, I am fitting that model to my trained data set X and Y. And now I'm predicting the output through my test data set. So this is, I am predicting it. So till here, I've created a model of random forest. I fit it to my trained data. And from that trained data, I have predicted my Y through my test data. Now, to evaluate how accurate your model is, we are using two methods. One is confusion matrix and another one is accuracy score. So this is again sklearn matrix. We are importing confusion matrix, and sklearn matrix we are importing accuracy score. And we have created this confusion matrix. We have applied to my y-test. Y-test basically is my predefined. Already I know what is my output, and y is my predicted output. To see what is this accuracy, so let's run this code. You can see it in the confusion matrix. Click my PC1, right? So my accuracy is coming 90%. So somebody must be getting 89, something like. And if I keep on running this, the accuracy will keep on increasing, because same data set you are running constantly. So your model is getting more overfitted, right? So I hope everybody must have run the code till here. Please can confirm. Okay, good. Now what I want from everybody, right? Please try with PC component 2 and 3. So for that, we got this code, and you guys tell me what is your PC, what is your when you select n component 2 and component 3. So I've already done for 1. So please, can you do it for 2 and 3 as well? If anybody gets an error, so what they can do is execute the previous code again, and then run yes, Vishimta and Vishal. As I mentioned, the more you execute the code, it will accuracy will keep on varying. Like you can see on my screen, my accuracy is coming 100%, and because I have used this code so many times, my model is run so many times now, it is 100% biased to. But yes, guys, so what you have observed over here, chances are high that the accuracy score would have gone lower for n component 2 or n component 3, and that is what is happening. Now you see, every time you run the code, the accuracy will keep on changing because your model is keeps on running. So now is more and more readable. He's more what we call overfitted to your data. So maybe if you remove everything, run this whole notebook codes back again, you will again see that the accuracy again got changed. Okay, so let me go through this whatever is read over here. With two principal components, the classifier accuracy was X as compared to Y for one component, right? X and Y is our previous. With three principal components, the classifier accuracy again increase and decreases, right? If you run that code, again it got changes, right? So from the above experimentation, we achieved optimal level of accuracy while significantly reducing the number of features in our data set. So now you have seen, like when I selected one feature, what was my output? When I selected two, what was my output, and so on. So this is what we have learned it in today's session. One is feature selection and one is feature extraction. So the general thumb rule is taken number of principal component that contribute to significant variations and ignore those with variance. So this is what the thumb rule of feature extraction, guys. Where which is having the highest variation, we select it, whichever is lower, it can just drop it. Okay. Now, to conclude this session for today's, I think half an hour before we have completed, that's good. Dimensionality reduction means keeping the important features and ignoring the redundant or less important features, right? Too many features lead to problem of curve of dimensionality. In the starting only, I've shown you that curve where we have one spot. As long as we increases the feature, our model accuracy keeps going down. With limited resource and limited time in hand, we should do dimensionality reduction either by feature selection or feature extraction. Right? If your knowledge about the data set, data source of the domain in which you are applying a model, then choose feature selection. I've already told you guys, if you know about your data set, you know about the terms being used, so you can go for the feature selection. Moreover, in text-based analytics and NLP applications, feature selection is mostly used, right? So any text-based data analysis, your neural NLP, you are using it. So you are using feature selection. If the data source and the data set is less known, then you should apply PCA, feature extraction, to decide the principal component. Right? If the data set is not known to you, so you can go for PCA. Both techniques are applied before consuming the data for training your ML model. So this is very, very important, guys. before building any model, any classifiers, any techniques you use to build a model, you should go for a feature selection or feature extraction to make sure your model should work perfectly. So for more information, you can Google online. You can go for Kaggle. This is the best data set source where you can get more data sets and all the information. There are huge data sets, huge data is everywhere now. Now everything is going on data only. So you can apply this PCAs to other data sets also and check your models accordingly. So that's it from my side. Thank you, team. Now over to you, team. Any question, any doubts, please feel free to ask me.
Or why use error for n equal to 3? It's giving error for n equal to 3.
Which one, sir?
1 and 2 is not a problem when I run for the third component. It gives error.
Yes. Why it gives you an error? Because when you have applied CA, so here this code, where it is. So that error is coming because you have already applied that PCA, this PCA to 1, right? So what it will do, it will keep one feature and remove both the features from your data set. So that data set is already got removed. So that's why if you run the second time, see that error, it is not finding that feature. It's existed or not. So it's going beyond its limit. So current data set while executing, and to avoid those kind of error, generally what happens is like we can rename this one, 1, 2, 3, something like that. The object which we created, we can rename that. That's why that error was coming.
Yeah, understood.
Sir,
Yes.
Diksha, I have one doubt.
Yeah.
Am I audible enough?
Yes, you are.
Yes. Sir, as we have seen that if we are running the model several times, the accuracy is getting 100%. In other words,
Right.
the model is overfitting to the data.
Overfitting. Yes.
Okay. So
Yeah.
in real world, obviously the model is going to run several times. So how to handle this overfitting problem in real world?
For overfitting issues, for that, I hope the next session, what you're going to cover in that, it is there. The how to overcome this overfit and underfit issues. So for that particular things, generally what we do is the test data, test whatever the test informations we are giving it to that. We generally hide that information from our model. We found it out as a sweet spot. We call it as a sweet spot. So not sure over here. There will be a session which covers you for this fitted and underfitted issue. The first basic rule, what we use it as hide that information. The input we are giving to that particular model, that information should be unknown to that particular model. If that information is given to that model, right, these issues get occurred. So for that, there are two techniques, Risha. to avoid this kind of problem, right? Let me tell you. We call it as best fit model. Basically, the term is called best fit model. And to find a spot, that's a method we call it. One second, let me update you. We call it as cross technique. Hello. Sorry, Visha, are you able to hear me?
Yes, sir. I am able to hear you.
Yeah. So we call that method is cross validation technique
Okay, sir. Thank you.
to avoid that issue. Generally, we call it cross validation technique. And this technique, let me explain, this technique is similar to what we did it in PC.
Thank you.
Right, rather than taking like 20% and splitting the data to 20/80, right? What we do is we take the whole data as our test data, right? And then what we do is we take one features at a time, right? In cross validation, if you go through this cross validation notebook, right, you will come to know. We'll take one feature and see what is our output. Then we take another one and then we take another. So that's how we create our model, and the model will not know what is its input influence. As I mentioned you in the bank, that bank data, whether it's a defaulter or not default. If you are having the data, which is more defaulters are there and less non-defaulters, and you put such kind of data to that model, so it will, if you give him the unknown data, what it will do, it will put you that it is a defaulter. When you know it's a not defaulter, still it will show you as a defaulter. So that's a technique. And another technique, we called it as what's that? Avoid this yeah, cross validation. In data selection, whenever we train that model, we do it like 50-50%. So we increase the data set and reduce the data set accordingly, right? So we called it a scaffold method. So this is the method generally we used it to overcome the problem of overfitting and underfitting our model. And in that, so generally when you do, have you done the exponential data analysis, EPD?
No, sir.
In this one, so generally whenever a new data comes to us, we do it EDP, and in the EDP we do lots of information. We check whether what is the percentage of what we call the data information, what we are getting it, what is the percentage. An example, as an example of defaulters and for non-defaulters. So we have a data set where the number of defaulters are less and the number of number of defaulters are more and non-defaulters are less. So in that case, what we do is we split the data into 50-50%. We take whole of defaulters and the non-defaulters, and the same numbers we take it for the non-defaulters, and we make it 50-50%. And then we trained our model. Are you getting it?
Yes.
Yeah. And similarly, there is another technique. We increase the data. We randomly generate some information for the output variable. Say an example, our output variable is 0 and 1, and 0 is more and 1 is less. So what we do, we randomly generate some data, randomly generate some information, and make our output like 50% 0, 50% 1. And then trained our model. So that's overcome your problem of overfitting and underfitting. So whenever we train any model, we do this activity. So I think more part it's still going to be covered, so, because we have lots of notebooks for those kind of things. I hope I was able to answer your question.
Sir, thank you.
You're welcome. Anything?
Anyone else has a question? Anything you want to discuss? Nothing?
I suggest you guys you go through the videos which is there in that link. That really going to help you a lot regarding that feature selection and feature extraction, because that's the one of the part of ML model. Before building any model, that need to be done 100% in any model we are creating. Whether it's a regression, classifier, or decision tree, random forest, NLP as well. So
Thank you, Amar. I think session is over. No more questions.
okay, thank you very much,
So
Surendra.
yeah, so thank you, Amar. Uh, for participants, he has delivered the session all the way from Ahmedabad. He was supposed to deliver the session from his office, but there was a lockdown now in Ahmedabad, so he has to deliver the session from home. So anything can happen nowadays. A lot of disruptions in our life, and still you guys are really able to cope up with this, and whatever is promised, you are able to deliver. Thanks a lot. Actually, when we conceptualize this FDP, there was only one challenge for me actually, and that was how do we conduct the practicals? Practicals, how to take it was very difficult, no? But then with Rocky and you and the entire team, now I am satisfied that okay, we did a good job with your help.
Yes.
Yes.
No, really, Rocky sir only taught me all this thing. Whatever I've given you the information is because of him only. So,
Yes.
and he took the sessions with us. We used to have a small batches. It's a very big batches, but we used to have in lockdown. It was happened in March when the lockdown started. I just connected Rocky sir, and the same way he is giving that lectures, the notebooks and everything, and executing the code, going through these codes and all, and along with the participant.
Yes.
So
He,
we do
he is
this
one.
for
He is one of the popular, one of the most popular external faculty
yes,
in our college
external
actually.
faculty.
In
Yes,
our college among the students,
right.
So yes, and जैसा गुरु वैसा चेला, तो आपने भी वैसे ही काम किया. So thank you very much. This does reflect
It's my
how
pleasure.
much, yes, this does reflect your teaching also reflected the Rocky sir style. So it does reflect how much teachers can impact the life of a student.
Right.
Student always try to emulate what the teacher does in a class. Same thing.
Right.
So thank you, Amar. Thank you very much. Thanks a lot. This is a kind of a virtual moment. तो हम यही दे सकते हैं भी आपको online mood. So
No
you
issue,
accepted.
sir. It's my pleasure. It's
Welcome and looking
thank you.
forward
Thank you
for
very much.
any time in future. If I need the help, I'll contact you again. Okay,
Sure,
sir.
definitely, sir. Thank
Thanks a
you.
lot.
Thank you very
Thank
much.
you
Thank
very
you,
much.
team. Yes,
Thanks a
take
lot.
care. Bye.
So everyone, thank you. Thanks a lot. Please join the sessions always on time. Request, kind request. Every time we cannot go on sharing the collab book. It disturbs the resource person. Please join on time.